there we go. So part 2, this is our Java section that we do, right? We always do a non-Java and then a Java part. Today we're going to talk about the anatomy of a class. So if you remember, on the first day we talked about making objects, right? We made our house objects. We said each house has its own characteristics. We used the string class, which, as you remember, the string class allowed us to create words, and then there were methods or actions that we could take with those objects, right? What could we do with our strings? We could get a substring, we could get the length, we could find the index of something, right? Characters. So we could look at that. So the idea of a class is a blueprint, if you remember from 2 sessions ago, that we use to create objects with. And we create multiple objects of these blueprints, and then we can manipulate them. And that is really the whole idea of object-oriented programming, the idea that all of our code is put together into classes, and there's rules and structures for these classes. And this stuff comes up a lot in the test. Not just the code within the classes, but the class structure themselves, and the idea of object-oriented programming characteristics. So we'll see that on there also. All right. So the anatomy of a class, we're going to actually make a class or look at how a class is designed so that we can then create objects with that. So we're going to basically talk about these 4 things. We're going to talk about constructors, which we use to construct the objects. And then we're going to talk about instance variables, which are the characteristics of our objects. So like in the house, it would be the color or the address, or we said each house had its own characteristics. We're going to call those instance variables. Methods, which we use methods. Those are the actions that we can take on our object, like give me a substring, or paint the house a different color, right? Or drive the car, something like that. And then we'll talk about scope. And scope, it gets a little more detail about where things are available and how you can reference different parts and what things are private and what things are public. And we'll get into that. And you'll see those type of questions come up a lot on the exam as well. And just had to throw a little Java thing in here also. All right. So here's our resources for this. It is in study.com in the Java Programming Guide. Chapter 6 is all about classes, methods, and objects. So that's a really good chapter if you after this unit, after this module, to kind of really get into that whole structure as well too. And it's presented a little bit different than I'm doing it here, but it's the same basic ideas. So it's another good resource for you. Of course, in study.com, chapter 7 and 8, the fundamentals and the basics, they have all the Java in those 2 chapters. So it's in there as well too. CS Awesome, I cut out sections I thought weren't necessary. So it's not just 5.1 to 5.14. I cut out ones that I'm like, oh, ignore that. You won't see anything like that, and it gets too confusing. Yay. So I kind of went through, like I got rid of like 5.3, 5.7, 5.10. I don't remember what they are, but specifically I'm like, just, we don't even want to bother with those. All right, so we start by talking about, before we actually get into a class, I want to talk about the idea of like a black box. The concept of a black box, not like an airplane black box, like, why don't they make the airplane out of the black box material? To survive. But a black box is something that does this thing. Like if I always tell my students, I'm like, if I put a radio in front of you, and I know you don't have radios, you have your phones, right? But if I put a radio, I think, could you make it play music? Yes. What would they do? They turn it on, they tune the dial, which they all still know about, to like, and they can name a station or two, like 96, I don't listen to the radio.
98.
98, not sure, any other, 102 rocks or whatever it is, and you turn it on, and then music comes out. Great, everyone knows how to make it work. Great, how does it work? Well, there's like signals that, okay, what does that mean? But how does it, and then the antenna picks up the signals. Great, how? Like, explain that to me. So it's like magic? It's like a wand? No, it's like there's a radio transmitter, okay? But how does it work? If I gave you all the pieces, could you build a radio? Of course not. You know why? We don't care. We don't need to know how to build a radio. We don't, because it's as long as you know how it works, that's all we care about. That's what a black box is. It magically does its thing. The idea of it hides its inner workings. I don't know how the volume thing works. I just know that I turn it up, it gets louder. It does, and I don't know how it does it. I still don't know. So 2 terms to talk about is encapsulation and abstraction. And the idea of encapsulation is putting all the common ideas together into a cohesive unit. And we're not going to have a class called stuff. We're not going to have a class called everything on the earth. We're going to have a car class, or we're going to have a person class, or even more specific, a student class, or a high school student class, right? We can get very specific about our objects, our classes to create these objects with. But then there might be some hiding of the details so that we can use it, but we don't know how and maybe there's some stuff goes on behind the scenes that we don't know how it works, and it just does it for us, right? A lot of times there's things that go on that, well, I did this and something happens, but yeah, you don't know about all the behind the scenes stuff. That's the idea of what a class does. Also, the idea of abstraction, it's the concept of what happens. Well, what happens when I turn the volume up? It gets louder. That's how it works. I turn the volume up. Up means loud, down means soft. Yeah, but that's not really how it works. You're just kind of explaining to me the process. It's kind of an abstract process, right? The radio signals go through and they hit the antenna. How? No idea. But that's what it does in an abstract way of explaining it to you. That's what abstraction is. So it simplifies complex systems. Some examples here, right? You may be a driver. You drive a car. You don't know how to build that car. Some of you might. I don't. You might know how to build that car, but you don't need to know how to build that car to drive it. You just know how to drive it. An automotive engineer designs that car and may use some of these electronic control units. But guess what? They don't know how those control units work. They know that if they take it and they put it in the car, it's going to make the lights go on. But they have no clue how this works because there's somewhere else that designed a car part and then use these little tiny electronic things that they may or may not know how those work, but that doesn't matter. They know how to put them together. And there's all those different levels. Same thing happens in software, where a computer user may use a program. Well, an applications programmer wrote that program, but then they may use objects or classes that make objects that someone else at a lower level designed. And they maybe the systems programmer who took all the operating system commands and or operating system protocols and put that together so those programs can run on that system. There's all different levels of that where people they don't know all the inner workings. They don't have to. When you have a large software system, one person did not write Microsoft Word. One person did not write Grand Theft Auto 6. Right?
No
it was
one's
like hundreds. The deranged mind, whoever it was that did it.
It's not out yet.
Oh, there you go. I would say something like, Fortnite 12, and they're like, but lots of people contribute to that, and they don't all know how it works. They just know that, okay, we're incorporating this now, and everything I'm using works, better work, right? And then that makes my part work, and it gets onto somewhere else. That's the same idea. So we take our computations, and we encapsulate them into what we call software really black boxes. A programmer who uses an object only needs to know about its behavior, not about how it's written. How does string work? No idea. But you could get substrings, you got index sub, you got the length, you used all these methods, and you had no idea how it worked. You can write your own classes, the programmer defining the class, that someone else might use. Now, in a lot of classes, students will develop their own classes and then use their own classes, right, as well. But as well as using other classes that other people have written, like string and other classes that are out there as part of the Java library. A programmer who's going to write their own class, so we're going to go through that a little bit here, you actually define the behavior first before deciding how it works, right? It's like you can't ask someone to, hey, build me a car, and they go, sure, no problem. And then they go, here's your car. You're like, whoa, that's not at all what I wanted. You have to figure out, how am I going to use it? What colors do I like? How big does it need to be, right? Define what the behavior is going to be, and then go through and do it. Now, what's great is you're not going to have to design any classes on the exam. However, you are going to have to read a class and understand, oh, that's a constructor, that's a method. And so they could give you, and you'll see some in the questions here. We're going to do a little class writing. I have some set up in a structure for you. But on the exam, you're not going to have to write any programs. It's all multiple choice questions, right? They may say, which of these choices would be a good implementation of this method, right? So that's kind of like writing, but it's multiple choice. So keep that in mind as well. All right, so let's talk about designing a class, a concept, an idea. We're going to start with a bank account. Everyone knows what a bank account is, right? We all have bank accounts. What are some things that you can do with a bank account? And if you see the slides, you already know the answers that I'm going to use. But there's lots of things, right?
Pay bills.
Well, yeah. So you can get very complex, you could say, oh, I can put in a payee and have that bank account transfer money from my account to all the different creditors that I owe money towards, whether it's the electric company, and then we get really, but let's go into like the basic Wild West bank account. Like the guy walks in to the saloon and goes, I'll open a bank account. They got the little drawers behind them, so I'll put your $10 here in this drawer. So what are some basic things you can do? You can deposit money, we can withdraw money. I can say, hey, how much money do I have? Like you go to an ATM, right? What do? You deposit, withdraw, you can check your balance before you withdraw, which is a good idea. And then, and I put this add interest as well, because just to show another feature. So you can say like every month, you can tell the bank account to add whatever low percentage interest you're getting. It's always something minor. So because these would be my behaviors, they're going to translate directly to methods. And so notice I put it like in Courier font, so it's like computerish looking. So I'm going to have a deposit method, withdraw method, a get balance method, and a add interest method, right? These are going to be the actions that I'm going to write the code for. What does it mean to deposit money? How does that change my object? What does it mean to withdraw money? So let's back up though a little. Before I get into these methods, let's talk about how do I make objects. So here's how I would make a bank account. We talked a little bit about this with strings, but what we would say is in Java, you say the name of the class, and then a variable name. Just like we said int age or double GPA, I'm going to say bank account, and I got to come up with a name for it, right? Don't call it X. Don't call it I. These are a little bit more, hefty, right? So I'm going to call this college fund. And then what do I do to construct it? I have to say equals new bank account. And that constructs a bank account for me. And I'll show you what happens when you say this. Now, what do you think this is right here?
The starting balance?
Yeah, so it's a parameter, right? And it's going to be my starting balance. Hey, I want to make a new bank account. I'm going to start out with $1,000, right? Or there's going to be an option I can make a bank account with nothing in there. And what's my balance probably going to be? Probably zero. But maybe you have a bank where they, open a new bank account, we throw $5 in.
Yeah.
I don't know, whatever it might be. How am I going to use this now? How am I going to make a deposit? Object.method, right? Name.substring, 0,2, whatever that was. When you did like the wrapper. College fund, object.method, deposit, parameter. What value am I depositing? $2,000. How does it work? We'll talk about that later. But this is just how we're using it. We want to make sure we know how we're going to use it first. What about transfer? You know what? Transfer is good. Maybe I should have a method for transfer. That would be a valid method to have. And say transfer money from this account to this account. But let's not do it. Let's find a simpler way to do that. Oh, you know what I could do? I could just define an amount and withdraw it from mom's savings and deposit it into dad's checking. That really is kind of a roundabout way of making a transfer, right? Because realize, and there's always that one kid that'll say like, well, but wait a minute, you haven't actually moved money. Well, when you, there's not, like the bank doesn't have these little drawers where they take the $10 out of your account and put a $10 bill into someone else's account, right? It's all electronic anyway. Right, there's not, you don't have a little jar with your savings account right now with dollar bills or gold coins or anything in there. So it's just keeping track of what they say you have, right? So if I come up with a variable amount, right, that's a double amount equals 500, that's $500. I withdraw that amount and then deposit that amount. I, in essence, have transferred $500 from mom's savings to dad's checking. Yeah. There you go. And these are, what type of methods? You remember we talked about two different types. There's mutator methods and there's accessor methods. There's ones that change the object.
Transfer's a mutator.
Deposit and withdraw would be mutator methods that changed my object. And then get balance would be a method that gave me some information. Remember we did this with rectangle, right? Get X, get Y were my accessor methods. Translate was my mutator method. Changed the X and the Y of my rectangle class. Remember we had the cereal box we did that with? Here, mom savings.get balance. What does get balance do? Oh, it gives me some information. What am I doing with that information? I put it in a print line statement. So what's going to get printed? Whatever it gives me when I call the get balance object method on the mom savings object, which I hope is how much money is in mom's savings account, if it works right. Good so far?
Mm-hmm.
So how about this? How would I use the methods of my bank account class if I wanted to empty dad's checking account? I want to empty dad's checking account. So how could I use the methods that I have?
Could you get the balance and
Okay.
then withdraw the
Withdraw.
balance?
Withdraw whatever that balance is. So what would this look like?
You have to deposit somewhere else.
Dad's
So let's assume it was already in there.
Right.
Right. Let's. I'm just gonna wipe it out. Right.
dad's checking dot withdraw, and then in parentheses get amount.
Remember, it's always object dot method anytime I call. So I agree. It's dad's checking dot withdraw, and then what's going to go in parentheses?
Dad's checking dot
Dad's
amount.
checking dot get balance is going to look
Yeah.
like that. Dad's. Oh, I put dad's savings. Sorry, that's a typo. That should say dad's checking.
Ooh, we're getting into the
Yeah.
savings. Yes.
Where am I at here? Oh, that's the wrong. That's not even the right. Hold on. This should be dad's checking.
Syntax error.
Yes. Of course it's. I gotta, come on. Semicolon. All right. Sorry, that should be dad's checking dot withdraw. Dad's checking dot get balance. Perfect. It's never wrong. All right. So these are the actions. I think we've got it covered. Deposit, withdraw, get balance. Add interest. We don't need anything else right now. We're going to keep our bank account simple. So let's define our methods. So when we define our methods in code, I'll hold this up here for a second. When we define our methods, so we're going to have to start by giving what we call a method declaration, or and this is going to look kind of familiar. Public static void main string args.
Mm-hmm.
That's a method. It's a main method that Java uses special. Remember, so we don't need to worry about all that stuff. You'll see how some of it comes into play. So let's say there's some methods I want. So here's how we define a method in class. So first off, you're going to have what we call an access specifier. Is this a public method or is it a private method? Public means anyone can use this method. This would be a method that if I have a bank account object, I should be able to use it. Think of private method as like internal use only. Like when like that line on that form that they don't want you to write on because it's for internal use only. Like you can't fill that part of the form out. Give it us, we got our own little system we got going. That's what a private method would be. Most of our methods are going to be public. In some of the pseudocode you see on the test, they don't even have public or private, but just for the ones that you see it on, you'll see that. It's going to have a return type. Do we get anything back? What are we getting? Am I getting a string back, a number back, or maybe I'm getting nothing back? What do you think we're going to put if you don't get anything back? Void. Void means you don't get anything back. The name of the method, deposit. Parameters, like amount. How much am I depositing? Right? And then the code is going to go in those curly braces. So here's what these methods are going to look like. There's no code in here right now. These are just the beginnings of all the methods. We said there's 4 methods, right? Deposit, withdraw, add interest, and get balance. 3 of them are mutator methods that don't return anything. You make a deposit, it's made. Make a withdrawal, it's made. You're not actually getting money back. You're just really decreasing your balance, right? And then add interest. Changes my bank account, right? All 3 of those change my bank account. But what does get balance do? Gives me some information, right? This was like the get width, get height. So notice that one's a little bit different because it says double get balance, meaning I'm going to get a return of a double back because get balance should return me a double. The other ones are voids, and the other ones have parameters, which they don't always have to have parameters. Like I need to know how much I'm depositing, or what's my interest rate. Sometimes you might just say, you might have a method called paint the house blue. And you know what that's going to do? It's going to paint the house blue. You didn't have to tell it anything else. No parameters needed. But sometimes maybe you just have a paint the house, and then you have a color parameter. So you could use that for any color you want. Depends. Again, programmers design choices, whatever they want to do. With me so far now, what goes in those curly braces? The code, the secrets. We'll get to it later. Cliffhangers. All right, so that's our beginnings. Remember we talked about what else do we have with classes? Well, we have our methods, but we also have our attributes, right? what would be, we haven't talked about that at all for the bank account. What are the attributes? What is my bank account based on all those actions? What is the bank account going to have to keep track of?
Money.
The money.
Yeah,
What should we
the
call
amount.
that?
The amount of money.
The amount of money in it, we call that the
total
Balance.
balance. We'll call it the balance, right? Just for, so we'll have so here, now you could also say, well, my bank account could also have my account number, my address, my name, a whole bunch of other things. Yep.
Phone number.
We're just gonna have the balance. We're gonna keep it simple, right? If these get more complex, lots of attributes, right, for my object. So here I've got a balance. Now, when I make here's my public class bank account, which you've already seen that in some of your code because that's where you have your main method. But now this is a separate class, separate file. Public class bank account, because that's the name of the class. We know it starts with that way. And then private double balance. This is my instance variable. How do we make an instance variable? It's usually private. Why is it private? I don't want somebody changing my balance from outside. You can't just go to an ATM and go, make my balance $4 million. You can't. You have to call the deposit method. The deposit method will check to make sure you actually put that check in the machine, and then it will add it to your balance itself. It'll take care of that. Balance is internal use only, so it's private. That's that whole public-private thing, right? What type of value is balance? It's a double. Why? Because it's a decimal number, it's money. And then balance. So we have, to make our variable, we have an access specifier, such as private, the type, and then the name. There's our variable. We only have one. We'll keep it simple. We'll just have one variable, balance. And we're going to manipulate that using deposit, withdraw, get balance, and add interest. Well, get balance won't manipulate it, but get the idea. All right. So when I make my objects, I could have a college fund, which has a balance of $1,000. That'll buy a book, right? Mom savings has a balance of $8,000. Two different bank accounts, two different objects, each have their own balance. Could I call methods on each of these objects and not affect the other one? Yes. We've done that before. Same idea. All right. So now we're working on implementing this class. We determined the methods that we needed. We determined our instance variable. And now we've got to implement the methods and the constructors. So what is the responsibility and what is the purpose for each one? Let's talk about the constructors first. Remember when we said bank account mom savings equals new, right? Just like we did that with equals new rectangle, we did the same thing. So what happens when I say equals new? The word new kicks off a constructor. My bank account is going to have two constructors because I'm going to have two different ways I can make a bank account. One would be kind of what we already looked at. Public bank account and my balance, and I'm going to set my, another typo, what's wrong? Init balance and initial balance. We're going to call this init balance so it matches. So I get for making up new slides for y'all. I haven't been like road tested as much. This, I'm going to have a parameter, and whatever that parameter is, what do I do with it? I assign it to my balance. That's it. Because that's what the initial balance should be. Hey, make a new bank account with $1,000. Guess what balance is going to be? $1,000. But what if I just say, make a new bank account and don't put anything in parentheses? Oh, it's going to make a bank account with a balance of 0. Now notice some things about the constructor. Two things about the way, now that's the code in here. I already showed you the code. But what do you notice about this first line, the declaration of these two constructors that's different from methods? So here are my methods right here, right? Public, void, deposit, parameters, public, double, get balance. What did you notice about the constructors? Two things. What's missing?
Void.
The void, the return type. There's no return type. Why? It's a constructor. It's just making my object. So there's no return type. No constructor return values. Second thing is, what do you notice the name of them is? It's bank account. It's the same name as the class. The constructor that's how you know it's a constructor, because it's called bank account. It's in the class bank account. Bank account has a constructor called bank account. House has a constructor called house, or multiple constructors called house. So now, okay, here's what we got so far. This is our class. It's getting so big, I had to put it on like 2 columns. Our bank account. We've got our instance variable, that's our balance. We've got our constructors. Oh my goodness. Now, I've read over these slides like 4 times. Now I'm like spotting errors. Forgot the parentheses there. We've got, and that's because that was cut and paste. Hold on. Oh my goodness. Hold on.
Did you forget the parentheses?
Okay, I didn't have parentheses
Oh,
here.
after bank account.
Sorry, I didn't have parentheses here, and that was a knit balance. It's to be the same. I swear I read over these slides. I even, when I came back, because I did these a while ago, I came back from spring break, and today I read over them again, and, you know.
Your brain filled in.
Anyway, yeah. So this is what we have so far, right? We have an instance variable, we have 2 constructors, we have 4 methods that we haven't seen the code for yet, but that's so far our class. Good? Okay, so let's kind of just refresh. What happens when I construct a bank account? So if I construct a bank account, college fund, what actually, this is called instantiating, right, or making an object. I say bank account, college fund equals bank account, new bank account 1000. So I'm going to make a new object of type bank account. The second constructor is called, because I gave it an initial balance, the parameter init balance is going to have $1,000 in it, because that's what it says. The balance instance field or instance variable is now going to be set to whatever initial balance was, and then I said it doesn't return a value, it doesn't return a value. It returns what we call an object reference. Now this variable holds a memory location. We talked about this with rectangle a little bit, of where that object is in my memory. You don't need to worry about that, Popper. Just know that that's what it is. And now college fund is what we call a reference variable. It's or an object variable, because it has a variable that holds the location of this entire object wherever that is in memory. We have this big object. Now I can manipulate this object, except I don't have any code in my methods yet. So what are the methods? Deposit, withdraw, get balance. So here's, and the code's nothing like big. What do you think deposit's gonna do?
Plus.
Okay, it's gonna take that parameter and do what with it?
Increase.
It's gonna add to my balance. Now, I did it a long way, but there's a purpose, so I'm gonna show you here. So look what deposit, now I'm gonna put the code in here. Deposit, I created a new variable called new balance, as opposed to like Nike or Adidas. So we just do new balance. Students don't laugh at that either. And what did I do? I took my balance and my amount, I added together, and I called that new balance, and now I said balance equals new balance. Could I have done this shorter?
Yeah.
Yes. Could I have just said, instead of those 2 lines, I could have just said, I could have just said, I don't think that works. Balance equals balance
Plus amount.
plus would have added 1, but I just want to add amount to it, right? Or could I have been even shorter? Could I have just said balance
Plus equals amount.
plus equals amount?
Yeah.
And that would have been just fine. I wanted to show creating a little variable inside my method, because we'll come back to that later. That's just the only reason I did that. But do you see that? And that's really all it does. Now, that's what our deposit method does. What would an actual bank's deposit method do? What would be some of the abstraction? They may go back and say, oh, you can only have 4 transactions per month. So maybe it has another transaction count variable that it adds to it, and if you've gone over the limit, it's now going to charge you an extra $5 because you did more than the 6 transactions, whatever it is you're supposed, right? There could be a lot of behind the scenes that I just tried to make a deposit. But there's all this other stuff that could be in there. That's the abstraction, right? Ours is simple though. What about stop. Hold on. Nope, it's still going. Okay. So there could be a whole bunch of other stuff other than what I'm doing. So our class is pretty simple, right? Here, wait for it, here we go. Get balance. This is an accessor method. It gives us some information. What does this do? Return balance. Doesn't print it, it gives it back to whoever asked for it. Now, remember I did mom savings.get balance? I had that in a print line. Mm-hmm. It returned my balance to wherever I asked for it. It puts it there. So what does the get balance method do? It just simply returns balance, which means send it back. Now, what type of value is it returning? A double. What type of value is balance? A double. They have to match. If I said return balance and I tried to return Tuesday, it wouldn't work because that's a string, right? So this has to return a value that matches what the return type is, which in this case is a double. And all I'm doing now, could it do, what if this was one of the projects I do in my class, a soda can class. And one of our methods is get volume. And the two instance variables is the diameter and the height. So what could this return? This could return a whole calculation. Pi r squared h, right, for the volume of a cylinder. So there could be more than just a value that gets returned. It could be a calculation, it could be a multiple thing. Whatever this is asking for, it could return, but it can only return one thing. So the answer to a calculation, a value, a variable, whatever that is. All right, so when I call momsavings.deposit, there's a lot of stuff that goes on, right? That's without even this whole transaction limit count or whatever. It sets my parameter variable amount to 500. It fetches the balance instance variable in my mom savings object. It adds amount to balance and puts it in my variable new balance, and then takes new balance and puts it into my balance. All that stuff happens when I call momsavings.deposit 500. All of that's behind the scenes. How does it work? If I didn't write the bank account class, I wouldn't care. If someone else did, as long as it worked, as long as I know my balance got changed, when I call get balance, it should reflect the deposit that I just made, I'm good. If it doesn't, we have issues, right? Good here? How about a withdraw method? Should withdraw be the same thing as just balance minus equals amount? Why not?
Well, because you might not have enough money to.
Yeah, you're gonna have to either stop it. at
So we
zero
need some more.
Be a FL.
Or,
So we're going to
yeah.
need an if. We need to have some checks in here. So check out the withdraw method. A little bit more complicated here. If my balance is greater than or equal to amount, oh, well then just say balance equals balance minus amount, which is how I could have done that over here. Could I have said balance minus equals amount?
Yes.
Yes. Otherwise, this is going to print out insufficient funds. You don't want to you go to ATM. So you're going to ATM and you're all teachers, you can relate. You're like, it's like playing the slots. I want $100. Like, come on, oh, okay, let me. Whew. Back in maybe our younger days,
College days.
but college days, right? But I'm sure when early teacher days as well too. You're like, oh, come on, it's like playing the slot machines. There, you're like try to withdraw and you use insufficient funds.
Every time it's target, please approve.
Yes, sir. Please come on. All right. Good so far. So now, what's the last one we haven't done? We haven't done add interest, right? So let's look at the add interest method. Okay, so we got a rate. So a rate, let's assume that's already in decimal form. It's not like 2.3%, I gotta say 0.023. It's already, let's assume it's already there. So I have to calculate my interest. What is my interest? My interest is gonna be my balance times my rate. That's how much I earn, but then what do I have to do with it? Add it to my balance. That's one way of doing that, the highlighted in yellow. Is everybody with me here on that?
Yeah.
So I take my balance times my interest rate. So if I get 10% interest, I have $100, I'm getting $10. And I'm going to add that $10 to my balance, I now have $110.
Okay.
Good here? All right. But rather than just do that, could I do this? Call a method from within another method. That works. Now, wait a minute. You say, hold on. Isn't it usually object.method? It is. But what object am I dealing with?
Add interest.
This whole bank account that I'm with, right? This is an internal. Could I call one of my other methods in the same class? Yes. And because maybe adding interest, again, maybe there's some behind the scenes work in the deposit method that even adding interest has to go through that, I don't know, whatever it is, report to the IRS if you're making too many, I don't know what it is, right? Whatever, So I could do that. One other thing you could do, which you probably won't ever see, because some people, they get it, no, it's object.method. I always have to have an object in front of my method, object.method. You can do that, you have to say this. Guess what this means? This object, the one I'm in right now. That's all. It's optional, you don't have to say that. This means we're referring to our own object, it's optional. Some people, there's some college professors that insist on always putting that in there. I think it just clutters up your code.
No, thank you.
I don't use it. But anyway, so let's look at our completed bank account class. So I'm going to pull that up. I've got that in JGraphs. Here is my bank account class. So let's look at everything together. I've got my balance, instance variable. I've got my bank account constructor, right? I've got another bank account constructor with a parameter, so I set my initial balance. I've got the deposit method. right? I've got my withdraw method, which, insufficient funds, right? And I've got my add interest method. We went through all this as well too. Oh, and then finally I got my get balance, which returns balance. That's my completed class. Sound good? So let's take a minute. Suddenly I have the Fresh Prince song in my head.
Oh, no.
Sit right there. I'll tell you how. Give me Prince of a town called Bel Air. All right, so let's look at this. Here is, you have this on your slide. It was kind of small to see up here. What does this? This is a main program that creates what? 3 bank accounts, right? This is in your slides as well. Mom's savings, college fund, and dad's checking. And then I call some mutator methods. Oh, look, I do a transfer. And then I call the get balance on each of them. Can you trace through and think, what is this going to print when I run this program? I have this program, we'll run it. But let's see if you can kind of take a minute and go, okay, well, I've got a bank account. Mom's savings got 8,000. College fund has 1,000. Dad's checking doesn't have anything in it, right? Figures. And, right, so now what happens when I try to do all this stuff? How do my accounts get modified? I'll give you a minute there. Okay, the first thing, so there's some print lines here, but there's something that gets printed at some other point before this.
Insufficient funds.
Yeah, when Dad's checking tries to withdraw
$100,000.
$100,000. Should I pull the answers?
Yeah.
Yeah.
All right.
Yep.
Yep.
Did you get that? Yes.
Yep.
Insufficient funds, 7,500. So mom's savings has 7,500. Why? Because it had 8,000, but then I withdrew I transferred 500 dad's checking. So now dad's checking has 500 in it, so he doesn't get that insufficient funds thing again. And then the college fund had 1,000, but then it deposited another 1,000 and then added 10% interest. So I do a little math there. So 2,000, 10% interest, $200. Now it's 2,200. If I run this, this is my bank account tester, same one right here. So when I run this code, there is the same insufficient funds, 7,500, 500, 2,200 as well. Both of those files, I'm going to play around with them, are in Module 3, so download those, play around with them, change them up if you want, whatever you do, just to become comfortable with classes. That's the anatomy of a class. Now I'm going to show you a couple more details. We'll answer a few questions, sample questions that you might see on the exam. But overall, any overall questions about the class? Kind of pulling the curtain back, right? Seeing how that works. All right. So let's talk about a couple of just details and attributes about these classes. Remember, can the deposit method access my instance variable balance? Yes, because the deposit method is in the same class as the instance variable, even though it's private. That's the internal use we talked about. I can add something to my balance here. In my main method, which, by the way, if you notice that, there's two files here. This is my main bank account tester, and then I had my bank account class. These are two different files. Each class, we have our own file. There's ways of combining a class with. It's usually, though, good to have everything separate in separate files. But you'll notice there's a bank account file and a bank account tester. This is my bank account class, and then in bank account tester, I use the bank account class, right, to make my objects. So this we know can do because deposit is in deposit is in the bank account class. However, could you just say in bank account tester, public static void main, oh look, main, it's a method, it's a parameter, we don't use that parameter. Void doesn't return anything, and it's public so that anyone can run this program. If I make a bank account, can I just print my account dot balance? No, because it's private. How would I print out my balance? I have to call the get balance method, which returns the balance to me. Make sense? So I can't just print out balance. Why? Because it's private. That's the idea of encapsulation and abstraction again. Encapsulation puts all that information in that black box and says, you ask me, like, you can't go to a radio and hit those two wires together in the back and make the volume go up. No. You've got to use that knob on the front to make the volume go up. You don't get to break into the radio and like hotwire it. It's not how the bank account works, right? You can't break into the ATM and say, make my balance $1 million. Maybe you could. All right, a couple other things. I want to talk about scope and variable types. We actually have talked about 3 different types of variable, not as in like integers, doubles, strings, rectangles, but where those variables are in my classes. We've talked about instance variables, right, which is like balance, and we say these have global scope. We can use these anywhere in the class, right, because it's outside of the methods, and now we can use it in deposit, withdraw, get balance, or add interest. Any of those can use my balance, right? That's what we call instance variable. It has global scope. It can be used anywhere in that class. A local variable, this is why I had that, is new balance. New balance, where was that made? That was just made in the deposit method, right? Could I use new balance in the add interest method? Nope. It only lives in the deposit method. It lives in those curly braces. We call that a local variable. That's why I did that, even though we could have done it a lot shorter. I wanted to make a local variable just inside of a method. So local variables have local scope or just like new balance. And then of course a parameter, the amount. We used amount in 3 or 4 different places, but each one of those was its own local variable that could be used again only in that method. Yeah?
So because we would still have new balance if we were withdrawing, we would have new balance if we were compiling interest, we would have to recreate that within those?
Correct. You would have its own version of a new balance variable if you wanted to do it the long way like I did in deposit. And you would not get an error. You could have a deposit new balance and a withdraw new balance in those each one of them, and it wouldn't give you an error because, oh, those are local to each one.
Okay.
Yeah, definitely, good comment. Does that make sense? So that's just the idea of scope. So a variable lives within its method, within its curly braces, or a class variable, a instance variable, lives, and we call that having global scope. It's a global variable, it can be used anywhere in the class because it's outside of the methods, right? It's still in the class, but it's not in a particular method. Whereas the parameters and the local variables are in that method. And that's why I use the word amount like 4 different times, because each method had its own version of the amount variable. All right, let's talk about some sample questions here. Here is not Java, Java-ish, pseudocode. It says, but it looks like they have a couple of methods. They have a method called function1, and they have another method called main program. Oh, and look, main program calls the function1 method. So they've got a main, and they've got another method, and then somewhere in the middle they got that int y. And the question's asking, which variable would be considered global? So this is all within one program. Which variable would be global here?
Is it W?
Well, where's W defined? That's
Function
a parameter in function 1. Parameters are local. What about X?
That's inside of function.
That's
as well.
inside of function 1 also. That's local. What about Y?
That's independent of any.
Do you notice how
methods.
Y is not in a method? Just like balance was not in a method. So we call the instance variables global.
So
What about Z? Z is in main program. It's in a method. The name of the method is called main program, but don't let main program think like it's always this big thing. It's just another method, right? So what's the answer for this gonna be?
why?
The answer is C, Y.
Why?
Why? See?
Wait.
Okay, I was thought that C was part of the answer.
What's that?
I thought C was part of the answer. I'm like, wait a minute.
Oh, sorry. It's choice A, B, C, and D. Sorry, and the answers are yeah. That's kind of weird to read.
Variables.
I literally cut and pasted that out of the sample question, so I will take that's like a picture. I can't edit that one. All right, what about this one? Oh, this is according to the pseudocode. So this has a class, and it says there's a test rank. Again, it's Java-ish, but I've got a test rectangle, and I've got a main program, and I've got a bunch of stuff, and it says which line constructs an instance of a class. Which line in here is construct an instance, or in other words, making an object. Give everybody a chance to kind of look at all. There's a lot of code there, and they're numbered. No one numbers their code one with like little parentheses after it there, like. But anyway, it's just for reference. So where am I actually making an object? Your thoughts?
9.
Line 9.
Yeah.
Yeah, I'm making a rectangle object with 4 equals. You know what's the key word that gives it away? New.
Yeah.
Right?
Yeah.
That means I'm constructing an object. Cool. It is line 9. Hey, how about this one? Which method can only, so there's methods here, there's a bunch of methods. This is a public class rectangle. Now, this is bad because there's no return types on any of the methods, and it just drives me nuts because that's just bad syntax, but this is the question, and they say this is within Java. But according to the code section below, which method can only be accessed from within the class rectangle? So think about what's that key word that determines whether or not a method can be accessed only internally or anywhere else outside.
Private.
So which method is the one that can only be accessed internally within the class rectangle?
Find area.
Find area. Yep. Because that's a private. The key is the private there, so it's internal use only. In an object-oriented programming language, encapsulation is most likely to be implemented by using, yeah, so the idea of private data and methods is the idea of we have private data and we're giving you actions to use to manipulate our object. That's what an encapsulation is. So we talk about that. So private data and methods. All right, here's one. This one says, I've got a class testing functions. And then I have another program, so I have testing functions called fun1 and fun2. It's fun because it says it. It's in the title. I have a variable here, x equals 5. Testing functions test equals new testing function. So I make a testing functions object, whatever that is, and I call test.fun2. So I call the fun2 method, I send it x. The question is going to be, what will be output? So think about what does fun2 do, and then what does, so give it a shot, see what you think. Trace through and you can see what's going to get printed here. Your thoughts?
4.
I'm still reading.
Oh, sorry.
Sorry.
Nope. So when I call fun2, what value is x that I'm sending to fun2?
5.
5. So do we agree that b is 5?
Initially,
Initially.
Okay, initially, but b is 5. But then what do I do to b?
you subtract 1.
So now what's b?
4.
4. So where am I sending this 4?
4 into fun 1.
I'm going to send it to fun 1. So what's a?
4.
A is 4. But then what do I do to a?
Add 1.
So now a is
5.
5. So what's going to get printed?
5.
5.
5.
Oh, we have to go back up to fund 1?
Alright,
Well,
Yeah.
because it says, it calls the fund one,
Minus
so
fund
the
one
main
B.
program calls fund 2.
Oh, yeah.
Fund 2 calls fund 1.
Right.
And fund, so what do I do? Fund 2 subtracted 1.
And then we add it
Fund
back.
1 added it back in, and then I printed it out.
Tricky.
Yeah.
It's so tricky.
Good here?
Can we run that program through our bills? That'd be nice.
Yes, exactly. All right. So in CS Awesome, I mentioned here's some sections you might want to check out. Multiple choice exercises are always really good. Here's the project that we're going to do. I'm going to show you these files and then follow along on the slides real quick, just for a couple of minutes. This is the one project we're going to do. There's an employee class and an employee tester class. So it's kind of like we do with bank accounts. So let me show you real quick what these do. I'm going to go ahead and look at the files. So employee looks like this. It's a blueprint for creating an employee object. So you'll notice in your slides here it says that an employee has 3 instance variables. It's got a first name, a last name, and an annual salary. So we just had balance. We're like much more complex now, right? 3 instance variables. I also have something called weeks per year. It's a constant, and we'll talk a little bit more about that, but basically it's a number that doesn't get changed. Right? Here's my employee constructor. If I have 3 parameters, can I initialize my instance variables with those parameters? So this would be what? First name equals,
Name.
well, there's 3
Well,
parameters here.
yeah.
Remember I had a knit balance, and I said balance equals a knit balance
Yeah.
to give a value. So which one of these do you think I should use for first name?
First.
First, so it'd be first name equals first. And then salary, right? And I use the 3 parameters to initialize my instance variables, right? Then, if you'll notice on the next slide, it says there are 4 methods that you need to complete. There's one called get initials, get weekly salary, give raise, which is kind of like add interest, because that's really what give raise is. So it's very similar to what we did. And then also get
Deposit,
annual
isn't it?
salary.
Wouldn't that be more like a deposit instead of an interest because it's not compounding?
Well, we're just saying we're giving them a percentage of rate or whatever, we're adding that to their salary.
Oh, okay.
So yeah, so we're doing that. So here's get initials. What does get initials do? It says it returns the first letter of the first name and the first letter of the last name. So I have, now remember, it doesn't have to return just a variable, it can return something complex. I'm returning first name plus substring, or first name substring 01 plus, how do I get the first initial of the last name?
Last name.
Good. Yeah, get it done. So we'll get it out, right? Either way, little spoilers, right? Get weekly salary. Well, I know my annual salary. By the way, there's 52 weeks per year. Can I find a way to calculate my weekly salary and return that?
Mm-hmm.
Yes. Can I give you a raise? This is, well, it says multiplied by the annual salary rate and added to the annual salary. I can't tell you to do it. But again, it's just the idea of doing that.
Yeah.
And then, how do I get my annual salary? I return as an instance variable somewhere, right? That's what that does. Now, in employee tester, I have this almost completely done for you. This is done. This, I created an employee called Agent 007, James Bond. He only makes $104,000.
Only.
License to kill ain't worth what it was at one point, you know? I can call Agent 007 get initials, and then my weekly salary, and then I give him a raise, and then I get the initials, and I say my new salary. So when I run this, I'm actually going to run my key version because it uses my, it should run my employee key. Hold on. This is my, I'm going to run my key so it actually works. So when I run this, it gives me, oh, hold on. No, it doesn't like it in my, that's the key version. Hold on, invalid method declaration. Because I called it employee instead of employee key. I tried to make a key and I had to call my constructor the same name as the class. So hold on, let me move this over here. And let's call this employee key. And so when I run this, I'll show you what you should get when you're done. Okay, so when you run this, and you have your employee, James Bond, initials, weekly salary, it gives you on the slide there what you should have, but it basically says, JB, weekly salary 2,000, JB, new salary 109,200, right? Then it says, hey, create another employee object with your first name, last name, any salary you wish, and then do the same thing, print your initials, weekly salary. Again, same thing, it's just a different object, right? All I want you to be comfortable with is completing the method code and then using the object that you just made. That's it. So from here, that's basically what we did. So you like John Smith returns JS, get weekly salary. It explains those methods. We've already done this. The main method already does the following for H007, James Bond. It prints that out. Create a new employee with your first name, initials, and then arrays, just like we did with James Bond. And so, to sum up, this is our next meeting is in 2 weeks. So now we're kind of every 2 weeks for these last ones. I would recommend going through CS Awesome Unit 5. Check out the questions. Unit 5 is all about class creation and class writing, but you don't have to write any classes. I would not do any exercises that have you write all these brand new classes. You're not going to do that on the test. But answer multiple choice questions at the bottom of CS Awesome. Download the sample Java files. I included bank account testers there, so you can check those out. And then go ahead for the assignment to submit. Make sure you submit the employee and employee tester with your new employee and submit it to eCanvas. I think it asks for a screenshot as well. And then the Module 3 quiz, which is all about networks and writing classes. And that's it. Look at that. 7:30.
Wow.
Boom. My clock's a minute fast too, so
7:29.
there we go. Questions, comments? How we doing? Feeling all right about that?
Yeah.
Good? So check those out. Bank accounts, very similar to what you'll be doing for employee. And again, there's not a lot of code right there.
No.
The point is not for you to have to write a lot of code, because you're not going to write any code on the test. But answer some multiple choice questions, those would be good, and then just finish the employee and then use that object. Use that class to make your object with your name in it as well. It'll work the same. Cool. I'll be around for about half an hour. If you have any other questions about this stuff or any other stuff in there, I'll stick around for a little while. Happy to answer those questions, and we'll go from there.
Thank you.
Thanks.
No problem. Thank you all for coming, especially first day after spring break.
I